Okay, today's lesson's on factoring and greatest common factor. Please write down the vocabulary words and definitions. Factors, numbers that multiply together to get another number. Prime number, a whole number greater than 1 whose only factors are 1 in itself. Composite number, a whole number greater than 1 that has more than 2 factors. Here's some examples. Factors of 12, 1 times 12, 2 times 6, 3 times 4, which means 12 is a composite number because it has more than one set of factors. Factors of 31, 1 times 31, which means 31 is a prime number because there's only one set of factors. There's different methods of factoring. There's the tree factoring or ladder. You should remember this from elementary school. If you're using tree factoring, you think of two numbers that multiply up to your number, like 8 times 6 is 48, and then you break those numbers down into the numbers that multiply to get them. So the factors of 48, if you go all the way down to prime numbers, 2 times 2 times 2 times 2 times 3, but you can think of other sets of factors for 48. For example, 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. All the sets of factors for 48. Now, if you want to use what's called the ladder factoring, you use, it looks like this. 2 goes into 52 26 times. 2 goes into 26 13 times. So the factors of 52 could be 1 times 52, 2 times 26, or 4 times 13. So if you see by rearranging your different prime factors, then you can get several different sets of factors. So prime factorization means expressing a whole number as the product of factors that are all primes. To find the prime factorization of these numbers, you can use either method of factoring. So this is 4 times 21, 2, 2, 3, 7. So the prime factors of 84 are 2 times 2 times 3 times 7. 2 goes into 90 45 times. 3 goes into 45 15 times. 3 goes into 15 5 times. So the factors of 90 are 2 times 3 times 3 times 5. If you have a negative number, the first thing you want to do is pull out the negative by multiplying by -1, and then go ahead and factor the way you would normally. For example, this is 132 is 2 times 66. 2 and 3. So for negative 132, it's going to be -1 times 2 times 2 times 3. Notice I only want the prime numbers. And what am I missing? 11. I can double check it. 3 times 11 is 33. Times 2 is 66. 66 times 2 is 132. Times -1 is negative 132. So go ahead and do the negative 140 on your own, and we'll check that in class together tomorrow. Factored form. That means factored completely. Expressed as the product of prime factors with no exponents greater than 1 on numbers or variables. So you factor each monomial completely. That means it's all separate, no exponents. So I'm just going to show you this. It's going to seem a little bit different at first, but you'll see when we get to greatest common factor why writing out the variables is important. So the first thing we're going to do is prime factor. Hold on. Technical difficulty. Two, 9, 3, and 3. So prime factoring 18x cubed y cubed. It's going to be 2 times 3 times 3 x, y, y, y. You do the same thing with negative 26. So negative 26 r s t squared is negative 1 times 2 times 13 times r times s times t times t. Okay, and you can go ahead and prime factor 12a squared b cubed and negative 66p q cubed, and we'll check that together in class tomorrow. Alright, so now we're going to do greatest common factor. The greatest common factor is the greatest number that is a factor of both original numbers. To find the GCF, you factor each number completely. Both numbers have to have a matching factor in order to be in common. Multiply the number of matches you find to get your answer. So 12 and 18. So the first thing we're going to do is find the prime factors of 12, which we did on the previous page of notes. So we're going to go 2 times 2 times 3. We already did our factor tree. And now what we're going to do is we're going to circle the common factors. So here the greatest common factor of 12 and 2 is 2 times 3, which is 6. So you see how that works? And then for 27, a squared b, 15, ab squared c, we've got 3 times 3 times 3, a, b, and then 3 times 5, a, b, b, c. And we're going to go ahead and circle our common factors. In this case, they share a 3, they share a b. So my greatest common factor here is going to be 3ab. So hopefully you're getting the hang of how to get greatest common factor. Now some of you may not need to go through all these steps, but I want to show you how to do it in case you ever come to a problem and you just have no idea where to start. This is a really good basic method for doing it. 15, your factors are 3 times 5. 16, your factors are 2 times 2 times 2 times 2. Notice they have no common factors, which means that they are prime to each other. There is no GCF. They are prime to each other. 36x squared y, 54x y squared z is going to be 2 times 2 times 3 times 3. And then 2 times 3 times 3 times 3, x,
Jason
y
Flores,
squared, z.
please come to the office. Your ride is here. Jason Flores, please come to the main office. Your ride is here to pick you up.
So here we've got the greatest common factor is, oops, I missed the 3. 2 times 3 times 3 times x times y. So that means that's going to be 18xy. Sometimes you'll have 3 numbers. I'll do the first one and let you finish the last one for homework. And you'll notice here they only share one factor, and that factor is 5. So your greatest common factor here is going to be 5. So you can go ahead and finish the other one for homework. Hopefully you're understanding this. If you have any questions, write them down and bring them to class.